Hello, I'm Olivier Ngubito and welcome to RPI Peras Kigali. We are seen in hydraulics and the pneumatic system, and we are dealing with especially electro-hydraulic system. So you remember last time we controlled our double acting cylinder automatically, but we have been using a directional control valve having two positions. And this time we're going to control again our cylinder automatically, but with a directional control valve having three positions, which means it's going to be 4-port, 3-position directional control valve. And it is a spring-centered. It has got 2 springs, and it has got 2 solenoids on each side. So if you have understood well the previous circuit that we did, I guess that you tried in your free time to analyze the circuit for the control for our double acting cylinder, because last time I told you to try to think about how to control an automatic cylinder using DCV having 3 positions, and that's what we're going to do. So first of all, remember this was our last circuit whereby we used to have 1 solenoid and we used to have 2 relay, and we said 1 relay was for isolating the information coming from the limit switch so that we can be able to use our switches, and we came up by using 2 relay. So for this time, since we have got 2 solenoid, so we're gonna use another relay and another solenoid, and we are just going to duplicate this circuit that we have here twice, which means we have the wall is for the first solenoid, and we do it again, the same circuit for the next solenoid, so that we can be able to control. But for the next solenoid, we shall be changing the limit switch 1 and the limit switch 2. Let me do it and see what we have. What I say is that we need to have 24 voltage and we need to have 0 voltage, just like that. And I'm going to put my S1, then S2, which is normal closed switch, you remember that well, and up to the relay. I'm going to call this the main relay, RM, let me call the main relay. And I need to have a self-holding for the main relay. So RM. Now it's time to copy this circuit for the first solenoid. And you can see I have to take it just after the S1. So I can say I better do this. And I go to here to R. That's going to be R2, R2. But because we decide to use main relay, so I'm going to start with Sol1 and R1. So I say this is R1. And I have to go to limit switch, normal closed, limit switch, number 2, and I go to relay. This will be R1, which is exactly this one, and I need to put the limit switch here, which is normal open limit switch, which is LS1, and I'm going to connect my solenoid. So I can take this to R2, to R1, because we are just using this R1, and then we go to solenoid 1, and we do the same. Again, we need to have to duplicate this for the next solenoid. So Since it is solenoid 2, so we're going to use relay 2. And we start again with R2 up to the limit switch, which is normal closed. And we go to relay 2, and here we have another limit switch, in parallel with that one, so that we can end up with having R2 here and solenoid 2. So if we used to have the limit switch 2 here to break the circuit, we're going to use limit switch 1 to break the other circuit, because if one solenoid is energized, the other need to be de-energized. If one is de-energized, the other need to be energized. So we're going to change the names, and we call this limit switch 2. Then this is going to be limit switch 1 in order to be changing. And one thing else, we need to be adding what we call interlocking for contactors or for relay, so that the two relays won't be energized at the same time in case you press switch. So we're going to use interlocking contacts. We break here, we put a normal close contact for the relay 2, and we do the same here. We break here and we put another normal close contact for R1. This means that in case we are using this rung, the R1 will be energized and it will have opened the R1 here, which means this line cannot be energized. If we are using the second line as R2, in case it is energized, it will have opened here, so this will not be energized. And what we want to add is that, what if in case our cylinder was stopped just before it reached the end forward or end reverse position? Like if it stopped from here. You know, on the first drawing, it was working because initially this limit switch was activated. So this time, we're going to imagine, like, since we use adhesive that can allow the cylinder to stop in the middle. So what will happen if we press the switch? Nothing will happen unless the limit switch 1 is activated or limit switch 2. So that's what we're going to solve by adding another contact of R1, such that when we press S1, we will be energizing the R1, and in case the limit switch 1 was not activated, neither limit switch 2, in order to have the current flowing to the one of the circuits, we need to take a contact for the main relay in parallel with either LS1 here or LS2. It depends on what you need. So I can put it here. Let's say we put it just here, either here or here. So I'm going to put it just here in parallel with. And I'm going to call it RM. And let me connect it now to see what comes out. So on my trainer kit, we changed from the DCV having having single solenoid, to a DCV having two solenoid and a spring centered, and the circuit is the same. So let's connect the circuit as we have it on the whiteboard. So we are supposed to move from 24 voltage to S1, from S1 to S2, from S2 to main relay. So let me rename the relays. if I take this as R1, let me take this as R2, and this is as RM, the main relay is going to be this one. So we move from S2 to main relay, and from main relay to 0 voltage, and we need a self-holding for the main relay. Just need to plug normal open contacts for the main relay parallel to S1. Then we need to proceed with, from the S1, we are going to ignore this one before, we shall put it at the end, but we are going to put R1 and the next. So from S1, this is the output of S1, which is exactly the same as this one. So we go from there, we go to R1, we say this is R1, normal open, and from R1, we go to limit switch to normal closed. This is limit switch to normal closed. And from limit switch to normal closed, we go to R2, normal open, normal closed. And this is R2, so we can plug here. So the normal closed, this time we move from up like that. Then we go to the relay coil for R1, which is that one. And R1 will need the 0 voltage. And we need to put this LS1 in parallel with R1. So it's here and here. Then we put it in parallel with R1. Remember, this is our R1. And we link the solenoid 1. We can take from the S1, we go to the R1. So we are here now. We are here. We go to R1. And our R1 is the first relay. So we can plug it from here. And we move from R1. We go to our solenoid 1. But before we go, we know which is the solenoid 1, which is the solenoid 2. We have to test it to see what makes, between the two solenoid, what makes the cylinder to extend, what makes the cylinder to retract, so you can test it easily. I'm going to just to test it with a rapid circuit. This is the ground that I connect. And I would just need to take directly the voltage from 24 voltage, and I will be plugging it either here or here when it is on, like this one. I can say I need to check which is solenoid 1, which is solenoid 2. If I press here, it moves. So this is my solenoid 1. If I press here, it moves back. So this is my solenoid 2. So this is the easiest way you can test it. So now we can say this is solenoid 1 and this is solenoid 2. Therefore, we can move from the switch here, or even here, because it's the same, because we just need to control the solenoid. And we go to, I've already connected this. So we need to move from that switch here to the solenoid 1. And from solenoid 1 to 0. Then we go to the next relay. Again, we will have to move from here, S1, between S1 and S2. So this is S1 and S2, so we can move from here, S1, here, and we go to R2. This is R2, but this time contacts normal open to there. And from that R2, we go to limit switch 1, normal closed. We go back here, but up, normal closed. And from that limit switch, from there, we're going to R1, normal closed, here as interlocking. This is our R1. Let's put it here. And from that, we go back. We go back to R2 coil here, and R2 will need the 0 voltage. You know, we can take it from here because we already have 0 voltage, or for here, the same. And we need now to connect this limit switch 2 normal open in parallel with R2. So we can take the 2 wires in this way, and we say this is R2, and you're going to connect them in parallel with limit switch 2. You can plug one here and one here. Then you make it to be parallel to the limit switch 2 normal open here and there. And we connect our solenoid 2. Let's take it from 24 voltage like here to R2. You can take it from it to here, R2, and from R2 we go to solenoid 2, which is this one, and from solenoid 2 to 0 voltage, just like this. So we are done with this, and remember we have for now we have ignored this this contact. So let's see what we have. I know it is not moving. If we press here, it goes for extension. It comes for retraction. It goes back for extension. And what if I stop it in the middle? Then I want to start once again. It won't work, just because we don't have this contact yet. So I'm going to plug this contact. If we want that in case we stop it in the middle, the cylinder should keep moving, so it will be connected here. And otherwise, if we want, in case it was stopped in the middle, when we start once again, the cylinder should have to come back before starting the initial stroke. Then we shall connect it here. So we're going to start by putting this here. So we take just 2 wires. Remember, it is RM, and this is our RM. So one is going to be connected here and another here. And this, if we connect them in parallel with LS1, like what we have on the above, one here and one here, you see that it's already on. And if you have to stop before that, and in case you want to connect it in parallel with the limit switch 2, you can repeat the same. This time we can put it here. And let's run to see what we have. You know, it comes back immediately. You see? We stop it from the middle, and then it has to come back before it goes for positive. We do it once again, we stop it, then it has to come back before, just like that. And in case we connect it to here, we take this back to here, one here and another here. We run again. And this time it has to keep moving. See, it keep moving. And we stop it. It has to go in front, just like that. So hope you have well catched all things that we say today. And this is the end of our video. And hope that you can compare what you did before and what we have here so that we can check. Thank you.